Today we're going to be talking about symmetry. And I have a picture of a snowflake here. And this snowflake has a lot of symmetry to it. So when you're looking at the snowflake, what symmetry is if you draw a line, that line there, and I would fold on that line, is that gonna fold right on top of each other? So I have another one here. I have another one here. Wonder if I folded it right there, if that would work. If I folded it right there, that would work. So you have a lot of symmetry. There's a lot of symmetry with this snowflake. I actually really like that picture. So line symmetry, and that's what I just talked about. Okay, figure has line symmetry or reflection symmetry if a figure can be mapped into itself by reflection across a line. So basically if you fold that line, so if you cut out whatever shape it is, fold it on that line and it lies right on top of each other. Okay, so our first example here, state whether that's where I got the word beaches. State whether the object appears to have line symmetry, right, yes or no. If so, copy the figure and draw all lines of symmetry. Well, where I stole this from, you see that there's lines of symmetry happening. So we have a crab here, a Dungeness crab. Looks kind of like a Dungeness crab to me. And if I were to fold it directly on this line, he appears to be symmetric. And actually, I challenge you to do that. Our faces appear to be symmetric. And in college, when I actually took a costuming class in college, and we actually looked at how not symmetrical our faces are. Anyway, but yes, so that's where our line symmetry here is. And then our starfish, okay, kind of like the snowflake. Across each one of these, we have some symmetry happening. This oyster here, okay, if I were to draw a line that way, because this piece kind of juts out over here versus this piece that's kind of inside, that's not symmetrical at all. I think that's an oyster or some sort of shell. Okay, order of symmetry. Number of times a figure maps onto itself as it rotates from 0 to 360 degrees. Okay, so if you look here, if you look down at my example here, we have 0 degrees. As I rotate to 45, it doesn't map on itself, but as I rotate to 90, it maps onto itself. It's the same thing. And so then at 270, it maps onto itself. So every time I rotate, our image ends up being the same thing. So if you look back at this, I have rotational symmetry because if I rotate this over there, I'm going to have rotational symmetry. It's going to be the same image, okay? The magnitude is the smallest angle in which a figure can be rotated onto itself. So the order and the magnitude are super important. If you notice here, in this example, I rotate 90 degrees, 180, 270. So my order would be 4. What's the smallest angle? Smallest angle would be 90 degrees that it maps onto itself. Okay, this example here. State whether the figure has rotational symmetry, right, yes or no. If so, locate the center of symmetry and state the order and the magnitude. Okay, so I have this point, kind of show us rotates to there. So I have 1, 2, 3, 4, and then 5 takes us back. So our order is 5. Take 360 divided by 5, And that gets our magnitude of 72 degrees. Rotational symmetry. So this point here rotates all the way around to there, across this center. Okay, and then this point here is going to rotate over to that point. Then I rotate over back to my original. So my order is 360, because there's 360 degrees in a circle, divided by 3, that's 120. And then we have this point rotating to that point, and so on. 2, 3, 4, 5, 6, 7, 8. 360 divided by 8 gets us 45 degrees. Okay, three-dimensional symmetries. So, three-dimensional figure is plane symmetry if the figure can be mapped onto itself by a reflection across a plane. Basically, if you slice it, you have two congruent pieces. That's how I look at it. A three-dimensional figure has axis symmetry if the figure can be mapped onto itself by a rotation between 0 and 360 degrees. So if I had like a triangle here, or even this cone, it kind of wraps around and it's on itself. Okay? So here, tell whether each has plane symmetry, axis symmetry, both, or neither. So can I slice this? Can I slice this along here? Oh, that's a really bad one. I don't want to draw that one in there. If I slice it basically halfway in between there, see all those? Those are all, that's a plane symmetry. Does not have rotational because I can't rotate this and have it be on itself because of this little piece up here. Plane symmetry, yes. I can slice this along here and we have plane symmetry. So same on the top and the bottom. And then we have a line that goes through where I could rotate around that, basically the center of that pentagon, and it's going to rotate along itself. So it has both plane and axis symmetry. Okay? Okay, so that is your video on symmetry.